Yes. All right. So another class of, we're just mainly going to kind of go through some homework problems. Some of this stuff we've talked about before in the past, and then you may see something new, but this is going to be mainly doing fraction arithmetic, as you can see, and we'll see if we can get to the scientific notation as well. If you saw the Math 154 video, I very quickly, in kind of passing, mentioned the scientific notation idea, that like a negative exponent meant move the decimal left, which also means that a positive exponent means move it right. But we'll actually work through some of that together ultimately. All right, so to add like fractions, you add the numerators and denominators, or denominators. So hold on, let's get some space. So remember, for your fractions, the words are numerator is the top, denominator is the bottom. Again, numerator, top. So if you have some fraction a over b, the numerator is the top and the denominator is the bottom. Hopefully that's not news, but just in case. To add like fractions. To be like fractions means that the bottoms match. To be like means the bottoms match. So I like to think about it this way. We're going very, very, very back to basics. You got a half a pizza. This is the half that's we have. And then you got another half of a pizza. An ugly black ink pizza. Hopefully it still tastes delicious, right? So we have a half of a pizza here, and we have a half of a pizza here. And they were both in their own boxes originally when we ordered them, but since we ate exactly half of our cheese pizza and half of our pepperoni pizza, there's no real reason, now that we're gonna throw this in the fridge, to have them in separate boxes, because I think we can just put them all in one box. And a half plus a half, if you stack them next to each other, so we're just gonna add them together, what you would get is, and in fact, let me do different colors for them. So black for the cheese pizza, and we'll go blue for the pepperoni pizza. So when you stack them together, here's your blue pepperoni pizza. I have too much fun sometimes. And here's your black cheese pizza. We had a half of each, and now you can see that this entire pie is taken up, and you have one whole. So that was a half plus a half made one whole. So it has to equal 1. So what that's saying is that 1/2 plus 1/2 is equal to 1. So to add like fractions, without even knowing how to do this, we can kind of figure it out backwards. We can reverse engineer it, if you will. Do we add the tops, the bottoms, or both in order to get this result? Well, let's see if we added everything. If we added a half, now I know I hit blue. Actually, I know I hit red. If I had a half plus a half, if I add the tops, you do 1 plus 1, which is 2, and if you add the bottom, 2 plus 2, which is 4. But we should know by now in this course, 2/4, you can reduce that as a fraction. 2 goes into 2 once and into 4 twice, which makes this equal to 1/2. And this answer does not agree with this answer. So by adding the tops and the bottoms, you say that a half plus a half is a half. That makes no sense. So something that we did must have been wrong. And what we did wrong was we shouldn't have added both things. It's only add the tops or only add the bottoms. So that was wrong. So let's try again. Let's say we were going to just add the bottoms for some reason. We have a half plus a half, and we add the bottoms. 2 plus 2 is 4, and we don't add the tops. We just, they match, so keep it a 1. First of all, it's extremely rare that the tops match. It is certainly possible in many times, but if you were just to think of any random math problem in the world involving fractions, they usually don't have matching tops. So, okay, well, they match, so let me just say we keep it and then only add the bottoms. And this answer does not agree with the logical answer, so that must be wrong. So adding both the top and the bottom was wrong. Adding the bottoms was wrong. Well, what if you just add the tops? A half plus a half. The 1 plus the 1 gives us a 2. We're going to keep the bottoms the same, and we know by reducing fractions, 2 will go into 2 once and into 2 once. So that's just 1 over 1. But 1 divided by 1 is just 1, and this answer does agree with the logical answer. Again, I just used a real concept, half a pizza in one box, half a pizza in another box. Don't waste space in your fridge, dump them in the same box. It will clearly make a full pie with, split ingredients, obviously. So that is just simple logic to try and figure out, well, oh man, I completely forgot how to add fractions. Do I add the tops? Do I add the bottoms? Or do I add both? Well, we clearly proved that adding both and adding just the bottoms did not work at all with a logical example. Just adding the numerators. And of course, after that, simplifying if you can, as we did. All right, fill in the blank with the most appropriate term or phrase. When subtracting 2 4/5 from 7, blah, 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 by writing 7 as 6 5/5. So here's the problem that they're talking about with this number 2. It threw me off because I saw 3 there. I was about to say 3. The word from means backwards. I'm pretty sure I've mentioned that either in this course or in Math 154. From is going to do the order backwards. So we're not going to do 2 4/5 minus 7. We're going to do 7 minus 2 4/5. And this is how you would set it up. You line up the holes and you line up the fractions. Now, the 7 doesn't have a fraction, which might be okay in some instances. Excuse me. If this was an addition, we wouldn't actually need it. We'd just say, well, 0 plus 4/5 is 4/5. But in the instance of subtraction, in this particular problem, it hurts us. If we had the 4/5 on the top instead, it wouldn't matter. It would actually be like that addition. You'd be saying, so again, what I'm saying here is an alternative world problem if it was 7 4/5 minus 2. This is like just having a 0 here. So 4/5 minus 0 is 4/5. And 7 minus 2 is 5. Again, this is a completely different problem. I'm just trying to give you an example of what it would look like if the fraction was on the top instead of the bottom for a subtraction problem. Give me 5 seconds. Okay. So again, we're here. This is what our homework problem is talking about. When you're doing the subtraction, they're suggesting that we need to write the 7 as 6 5/5. This concept right here is the same as borrowing. This is exactly the same idea as if we were trying to do, I don't know, let's go with 51 minus 38. You can't do 1 minus 8 when you have a subtraction going on like this. Yes, if 1 minus 8 is the problem, that would be -7. We can do our signed arithmetic. But you can't do signed arithmetic inside of a regular subtraction problem. It's trying to do too many weird things at once. So we can't do the 1 minus 8, so we borrow. So we got to borrow from the 5. When we borrow from the 5, we make it a 4. Now what I'm borrowing, since that 5 is in the tens digit, is I'm borrowing 10. I'm making that 5 a 4, so it's like taking the 50 and making it 40. But I don't just delete that 10, I'm just going to put it somewhere else, somewhere where it's more useful, and it's more useful over here in the ones. So this 1, I'm going to add that 10 to it, and it makes it 11, because now we can say, oh, 11 minus 8 is 3, and 4 minus 3 is 1, and the answer is 13. Now, I hope that you all know how to borrow. I hope that the skill you still have. If not, you need to go do 100 to 1,000 of them, and then hopefully you've got it down. Borrowing for fractions works a little differently. So in this empty space, what we need is a fraction that will be very easily, let me start that phrase over. We want a fraction here that we would have an easy time subtracting 4/5 from. Now, we're going to borrow from this 7. So when we borrow from this 7, just like when we borrowed from this 5, it goes down 1. It turns into a 6. But that was borrowing 1 whole. We didn't borrow 10, so it's not like this thing right here becomes a 10. We borrowed a whole, and now we're just going to put that 1 whole here. Now I'm going to erase what I have in a second. But I just borrowed the 1 here, which brought the 7 down to a 6, and now I put it over here. In the same instance, I borrowed 10 from the 5 and put it over here. But I don't want to write it as a 1 because this isn't helpful, because now I've got written 1 minus 4/5, and you need fractions to be like in order to subtract them. You need to have matching denominators. So the idea is, when you borrow this whole, the fraction that goes here should be the same number, top and bottom, as, I can't fit denominator there, as the denominator below. In other words, whatever this number is what you want to put here, top and bottom. Now, why does that work? Because any number divided by itself is 1. So that 1 that we borrowed, we could choose to write it as 3 over 3. We could choose to write it as a million over a million. We could choose to write it over as 17 over 17. We could choose to write it as 50 over 50. Because as long as we write the same number top and bottom, it's 1. So it represents the 1 whole we borrowed from the 7 that made it a 6. Why do we want these to be the same number as the denominator? Because then you have an LCD. You have matching denominators, which means you can just combine the tops. I want that 5 uncircled. There we go. So that's why we make that a 5/5. So we turn the 7 into 6 5/5. So when subtracting 2 4/5 from 7 by writing the 7 as 6 5/5, are we simplifying or are we regrouping? I don't know that we simplified anything. I would say we regrouped it because we just took a 1 that was over here and we put it over here instead. It's like we had an orange sitting in our pile of apples and we went, nah, we need that orange over here in the pile of oranges. We regrouped it. All right. For these simpler fraction problems, we're going to just kind of rock and roll through them. 7/12 plus 7/12. It even tells us that they're like, actually, no, it doesn't. I'm sorry. I thought it said like there somewhere. Add and simplify. This denominator matches this one, so we're good to go. We can just combine the tops. 7 plus 7 is 14. So 14 over 12 is our answer, he said with inflection in his voice. Let's hit enter and see what it says. Although your answer is equal to the correct answer, it's not in the correct form. Be sure and read the instructions. In particular, the instructions here say simplify. Now, even if it didn't say simplify, in the world of math, you reduce any fraction you can as an answer. So that 14 over 12, 2 goes into both 7 and 6 times respectively. Now, you could, if you really wanted to, you could certainly convert this to a mixed number. 6 goes into 7 one time with the remainder of 1, so it's 1 1/6. Again, that's just doing the long division. I took the 6 into 7. 6 goes into 7 once. 1 times 6 is 6. Subtracting, you get 1. That's your remainder. That's your quotient. The quotient is this number. The remainder is that number. The quotient is how many times it actually divides. The remainder is what remains to be divided. It literally tells you that it remains to be divided. You didn't do it. Now, if I type 1 1/6, let's see, let's hit our mix button, 1 1/6, because I chose to do this. And it actually gives you the correct, man, that actually surprised me. I'm thrown off. So normally what happens if they ask for a simplified fraction, if they don't ask for a mixed number explicitly, in most courses, my math lab will mark it wrong. So that's what I was expecting. But it marked it right, so that's kind of cool for y'all. They're being a little more lenient. So my math lab is actually saying, I'll take the 7/6 or the 1 1/6, and just trust me that the 7/6 would have worked. I can't retype the answer and get it correct a second time. And if I hit similar question, the numbers will change. So here's the thing. The mixed number is nice to gauge the size of it. It's 1 and some change. But what if you made a mistake in this conversion? Now you've got it wrong when the answer was right here. So this is actually just more work that if I don't feel the need to do it for like size comparison or some other reason, or they just flat out tell me write it as a mixed number, I shouldn't do it because more work means more room to make mistakes. All right, 3/13 plus 2/13 plus 1/13. Oh no, there's 3 fractions. Whatever do we do? Same thing we did with 2. If they all have matching bottoms, add the tops. 3 plus 2 plus 1. Some people even take this and write it in an expanded form. They don't simplify it first. They just go ahead and combine the tops, show the addition, then actually add it. That's perfectly fine. If you don't write the middleman, if you just go straight from here to here, that's fine. If you need to write the middleman, write the middleman. I don't think 6/13 reduces. Now this time they actually do say type a whole number, fraction, or mixed number, so I would have expected anything to work in that case, but not last time. But that's all right. Technology can always surprise us, like before class today. Har, har, har. And we got that right if you didn't see. All right, now we're getting to the juicy stuff. Now we're getting to the part where they don't have matching bottoms. So that means what we have to do is the whole LCD process, which we have discussed in great detail in the past. If you haven't figured that out yet, that means you need to go and do 100 more of them, or start your 100 if you haven't started any at all. All right, so we got 2/3 plus 1/2. I almost wish this wasn't a 2 in the top, but that's okay. So you got to find your LCD with whatever method you like. And I've talked about how you can list the multiples of the bottoms until you find a match. I've talked about how you can prime factorize the bottoms. And then your LCD is the product of all those unique primes, where if you have multiples in any denominators, you take the most. So let's find our LCD. If you do the multiples, 3, 6, 9, 12, 2, 4, 6, 8, 10, 12, you might say, oh, 12 is the LCD. 12 is a common denominator, but the first match was actually 6. 3, 6, 2, 4, 6. The cool thing about this problem is because there are no common factors, there's no number besides 1 that goes into both 2 and 3. The LCD is just a product of those. That doesn't work if your denominators are, say, 2 and 6, because there's a number that goes into both 2 and 6. So the LCD is not 12, it actually ends up being 6. Or something like 6 and 9. You can't say the LCD is 6 times 9 because there's a number that goes into both 6 and 9, 3. But again, with numbers like, say, 13 and 7, if those were your bottoms, you could just multiply them because there's no number besides 1 that goes into 13 and 7. All right, so here's what we do. We rewrite our fractions a little more spaced out than that with the LCD that we chose. You just change the denominators to 6. If we go back to that pizza problem, that's like saying, and I'm going to erase this because it's not relevant to the problem, but our half, let's say we needed to say its denominator was 6 because maybe they were just sliced differently. Us changing the denominator from 2 to 6 is equivalent to just making more slices. So you slice it this way, and then you slice it this way, and now you have 1, 2, 3, 4, 5, 6 slices. And there we go. Okay. But to figure out the tops, it's not just automatically 2 and 1. You don't keep the same tops. The only time you ever keep the same top is if the bottom doesn't change. If the bottom doesn't change, the top doesn't change. This is where we're doing that stuff to the side where it's a division and a multiplication. And remember, if you don't trust yourself with this, if you think you're multiplying or dividing the wrong numbers, then reduce the fraction after you get your, what I have in the black ink, and see if you still get the red ink. There you go, easy as pie. Check yourself, ask yourself, does it make sense? All right, so for the first fraction, we're taking the 6 and dividing it by the 3. You take the bottom and divide it by the bottom, and you do it in the logistical order, the bigger divided by the smaller, which is 2. Then we take that 2 and we multiply it by the top, which was coincidentally a 2 as well. 2 times 2 is 4, which that should be our new numerator. This is what goes here. Oh, I don't trust that. Okay, well, 2 goes in both 4 and 6. 2 goes in 4 twice, and a 3, sorry, and yeah, in the 6 3 times. For the second one, we're taking the 6 and dividing the 2. We're dividing the bottoms. Essentially, we're finding our scale factor here. It's actually kind of the same idea as proportions. So 6 divided by the 2, which is 3. And then we take that 3 and we multiply it by the top. Oopsies. We multiply it by the 1. which is 3. And then this is our new top. And then we have 4 over 6 plus 2 over 3, which will give us 7 over 12, right? No. What did I do wrong? I added the top and the bottom. All we were supposed to add was the top. It's 7 over 6. The idea is like when we had that half a pizza and that half a pizza, if they're all sliced the same way, you're only adding the slices together. They're still cut in halves. So you take 1/2 plus 1/2. Now you have 2 halves. Let's see if that gives us the answer. So it says type a whole number or simplified fraction. After that previous example, I'm willing to bet if you typed in 1 and 1/6, it would be correct, but I'm not gonna test my luck today. 7/6, boom, we got it, because 7 over 6 was irreducible. You couldn't reduce it. I thought I hit next problem. All right, 7 over 10 plus 4 over 90. So between 10 and 90, if you go with multiples, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, etc. Multiples of 90 would be 90, 180, 270, 360, etc. But you may have noticed I already got a match, 90. So what do? We write our denominators as the new LCD. That's the new denominator. And then we divide and multiply to figure out what the new tops will be. So for the first fraction, you're taking 90 divided by 10, which is 9. Then you take that result and multiply it by the top, which is not a 2, a 7. Why did I write 2? I had 7 in my head. 9 times 7 is 63, which is the new top. If the bottom changes, the top better change. For the second one, I don't know why I did that. We say 90 divided by 90 is 1. We take that 1 and we multiply it by the top. 1 times 4 is 4. The bottom didn't change, so the top doesn't change. So that first pizza was sliced 10 ways originally, and now we got to slice it 90 ways. That sounds cumbersome. Please don't try and do that. I can't imagine how skinny those slices are going to be. But the second pizza was already sliced 90 ways, so we don't need to reslice it. All right, so 63 plus 4 is 67, and then that's over 90. There aren't a lot of numbers that go into 90 in terms of small numbers. 2 because it's even, 5 and 10 because it ends in 0, 3 because 9 plus 0 is 9 and 9 is divisible by 3. Well, 67 is not divisible by 2 or 5 or 10 because it doesn't end in an even number or a 5 or a 0. And it's not divisible by 3 because 6 plus 7 is 13 and 13 is not divisible by 3. So it seems like that is the answer. It seems like that's reduced. Hopefully we went through all the prospects. 67 over 90. We got it right. That one's similar. 30 minutes. Yes, here we go. 2/9 plus 1/15 plus 2 over 21. I will do this LCD both ways. For the multiples, your multiples of 9 are, I might need more room than that actually. 9, 18, 27, 36, 45, 54, 63, 72, 81, 90. All right, well, let's stop there. The list is getting kind of long. I might need more space though, so comma. Actually, I know what I can do is maximize. Then for the 15, I'll leave space just in case. We got 15, 30, 45. Ooh, a match. 45 is a match, so that's the LCD, right? Well, no, we got to worry about the 21 too. I'm at least going to go out to the 90. So 45 and then 60, then 75 and then 90. Ooh, 90 is a match again. So we got some possibilities. Maybe it's 45, maybe it's 90. Now you might say, well, if 45 doesn't work, why would 90 work? Well, maybe 21 has a multiple that is 90 but not 45. I'm just saying these are possibilities for now. All right, how about the 21? 21, 42, 63. Ooh, 63 matches the first and the third, but not the middle one. Dang. All right, how about 84? What just happened there? Guess I wrote a comma and didn't realize it. I got excited for the number. That threw me off now. All right, 21 plus 84 is 105. Well, we didn't hit the 45 that we had a match before. We didn't hit the 90. And your time with that would be 126. And you might keep going. Well, let's go back to the 9. I'm just going to keep moving. So 99 would be the next. Then 108 would be the next. Then 117 would be the next. Then 126 would be the next. Then 135 would be the next. Oh my Lord, is this still going? Okay, how about the 15 multiples? The next one would be 105. Oh man, 105 matches here, but not on this one. After that would be 120, then 135. Ooh, 135. Maybe the next one for 21 is 135. Well, no, unfortunately, the next adding of 21 would be 147. And you start getting frustrated, and you get really frustrated. And this is why I teach multiple methods. So maybe I'll come back to this. Maybe I will. But I did this for a reason that, again, doing the multiples was really quickly for the last 2 problems. Not this one. Maybe more than 2 problems, actually. So this got tedious, which it's not always. Again, if your denominators are 2 and 6, you're going to find it quickly. If your denominators are 5 and 6 or 3 and 7, you're going to find it quickly. When you're dealing with multiple denominators that have multiple common factors, this starts to kind of suck. So let's try it the other way. So instead of doing the multiples of 9, let's write 9 as 3 times 3. Let's write 15 as 3 times 5. And let's write 21 as 3 times 7. Okay, so then our LCD, what we do is we have all the different factors. I see 3s, I see 5s, and I see 7s. Yes, the last 2 are singular, but just go with it. Your LCD needs all of those things. It needs some 3s, it needs some 5s, and it needs some 7s. But remember, you take the most out of your options. This is where people mess up. So there's 2 3s in the first option, there's 1 in the second and 1 in the third. The most 3s I see from an option is 2 of them, so I need 2 3s. I only see a single 5. I only see a single 7. So that's our LCD. And let's see, oops, red. 3 times 3 is 9. 9 times 5 is 45. 45 times 7 is 315. So our LCD is 315. And you can see that that was going to take us a very long time to get to. I wasn't even halfway there. So that's something that you could do if you understand both methods. If you think that the multiple, I mean, 9, 15, and 21, these are all small numbers. So maybe I can just list the multiples really and get it done really quickly. Ooh, maybe not. Oh, dang. Ooh, geez, when is this going to happen? And it may have been the next couple of numbers. I don't know. You don't know. It's just whenever you find the match. This isn't even the worst it possibly could be. There are LCDs in the thousands of digits sometimes. Not really in this course, but in math in general. Can you imagine having to list all those multiples? It would take you an hour, maybe 2 hours, versus just understanding the prime factorization version and boom, getting the LCD rather quickly. So now let's go back to our fractions and let's rewrite our denominators as 315. And remember, you can pull out your calculators for this stuff. When you do 315 divided by 9, you're going to get 35. So I'm not going to, I lied, I am going to. There's a lot going on. So this is still the same problem. I'm just showing you how to get the new numerators. For the first, we do 315 divided by 9, which is going to be 35. Then we take that number and we go 35 times the original numerator, which is 2, and that's 70. So that's our new top. For the second one, excuse me, we take 315 and we divide it by the 15, which would be 21, right? Yes, 21. There's a really quick way to get this answer, but it's only quick if you've practiced it a lot. I don't want to say this. The LCD has the 3, the 3, the 5, and the 7. The 15 have the 3 and the 5, so you just get rid of those, and that's what the division would be, 21. That's the trick. But I don't want you to focus on that too much if that made no sense. Then you take your 21 and you multiply by the top, which is 1, and you get 21, so that's our new top. For the third, we do the 315 divided by the 21. All right, so 315 divided by 21, 21's got a 3 and a 7, so if you cover those up, just one of the 3s, 3 times 5 is 15, I bet that's what the answer is. And if you check your division, 315 divided by 21 is certainly 15. And then we take that value and multiply by the top, which was 2, and that's 30. So that's our new numerator. And all we have left to do, hopefully, is combine the tops. Maybe we had to reduce after that. Now you could certainly say 70 plus 21 is 91, and then 91 plus 30 is 121. And without a calculator, that's not awful, but addition, the order never matters. When you start throwing in, adding and subtracting, the order matters. If you're subtracting, the order matters. But if you're only adding, or if you're only multiplying, the order never matters. I noticed 7 and 30 fit really well together. 70 and 30 is 100. So in my head, I actually add the 70 and the 30 to get 100, and then tag on the 21 to get the 121 over your 315. But you can certainly do 70 plus 21 is 91, 91 plus 30 is 121. You might be saying, Mr. Beckner, why would you want to do the addition in any order that it's not seen? Again, convenience. I noticed that 70 and 30 are kind of like yin and yang with each other. They form a nice, pretty, even 100. So sometimes numbers are easier to add out of order. And then you go, oh no, are there any common factors? Well, if you know your primes really well, 121 is just 11 times 11. So 11 is the only number that goes in the top. 11 is the only number that goes in the top. Factors of 11, 11 and 121. 11 does not go in the bottom. We showed that 11 doesn't go in the bottom because it's 3 times 3 times 5 times 7. So this should be the answer, 121 over 315. Let's cross our fingers. Oh, put that on the wrong side. There we go. 121 over 315, unless I made a visual boo-boo somewhere. Thankfully, I did not. And we can move on. All right, adding mixed numbers. I've already kind of talked about this. You just add the wholes and you add the fractions. So 39 is whole. The 8.5 has got a fraction part, so you line up the wholes and you line up the fractions. There was no fraction for the first one, so you don't write anything. If you wanted to write a fraction here, 0 over whatever is a perfectly fine fraction. You can call that 0 halves if you absolutely want to. You can put that 0 over any number you want to, but 0 halves would give you an LCD. But this is easy. Nothing plus a half is a half. 9 plus 8 is 17, carrier 1, 3 plus 1 is 4. So you should get 47.5, and they did say they want it as a mixed number. Although they did also say fraction, so maybe they would take whatever that is converted, 47 times 2, and then add the 1. 47 times 2 is what, 94, so 95 halves. I absolutely know 47.5 is correct. I want to see if they'll take the other one, which again would be 95 halves. Let's see if they'll take it. Me personally, I wouldn't do this because they gave me mixed numbers. We should probably keep the answer as mixed numbers. but maybe you're just a little wacky, and they gave us credit for it either way. That's nice. Again, pre-calc shells, they aren't so nice. Ow, ooh, I just hit my heel. That's smarts. All right, well, this is a much more interesting problem. 2 2/5 plus 5 4/5. No, you don't have to write these vertically, but I really do suggest it. Add the fractions. Well, the denominators match. That's awesome of them to set that up for us. 2 plus 4 is 6. So we get 6/5, then 2 plus 5 is 7. So the answer is 7 6/5 question mark. So let's not convert that to an improper fraction. Let's see if they'll give us credit for this. And I think I've already gave you a hint that they, whether they will or not, with that question mark. There we go. They didn't give us credit for it, as they shouldn't. Although your answer is equal to the correct answer, it is not in the correct form. Now, they don't actually tell you what's wrong with this. Again, my math lab is not here to tell you everything that you did wrong, and it always can't predict it either. What did we do wrong? Well, here's what's wrong. This is a mixed number, 2 2/5, 5 4/5, so the answer should be a mixed number still, but it's not mixed properly. This right here is an improper fraction, and it's in a mixed number. That's a no-no. You cannot have an answer that has an improper fraction in a mixed number. You either need just an improper fraction or you need just a mixed number. So here's what you have to do. Just take that number, just take the improper fraction is what I'm abbreviating there, and convert it. And then add the whole. That's how you fix that. You'll take the 6/5, you'll do the long division to convert it to a mixed number, and then you'll just add that to the whole, which was the 7 in this instance. Let me just pull back a little. So the 6/5, we would say 5 goes into 6 once with a remainder of 1. Do you need to see that? 5 into 6. 5 goes into 6 once. 1 times 5 is 5. Subtracting, you get 1, which is your remainder. This 1 is the quotient. I will write the 1 from the remainder in blue so that you can distinguish them. There we go. The quotient is the whole. The remainder is what remains to be divided. So the 7 6/5 is now 7 plus 1 1/5. And 7 plus 1 is 8. So the answer should be 8 1/5. Let's try that out. Mixed number 8 1/5. Drum roll. Ba-da-da-da-da-da. Now we got it right. Same number, just looks different. Right. What about when we have mixed numbers with different denominators? Well, just get all of them to have the same denominator. So we'll take our 2 1/2 plus our, do I need a little more space? 2 1/2 plus the 3 plus the 15 1/7. Now, since we're adding, yes, we can get an LCD for the 3 and the blank, but it's going to be pointless because it would just be 0 7ths, 0 halves, 0 thirds, 0 fifths, whatever it would be. So we just really need to focus on the top and the bottom. The LCD between 2 and 7 is 14. I will leave you to establish that. So this problem would be equivalent to 2 and something over 14 plus 3, and we're not worried about that one, plus the 15 and something over 14. I'm not going to show the work this time. I'm just going to talk through it. You can show the work if you have to. 7 goes into 14 twice, or you can say 14 divided by 7 is 2. Either way, it's the same thing. So 14 divided by 7 is 2. Multiply by the top, 2 times 1 is 2. Don't trust me? Reduce this, you'll get the 1/7. For the top one, 2 goes into 14 7 times, or you can say 14 divided by 2 is 7. Multiply by the top, 7 times 1 is 7. Don't trust me? It reduces perfectly. Then we can add everything now that we have matching denominators or just a blank. 7 plus 2 is 9, so 9/14. 2 plus 3 is 5. 5 plus 15 is 20. 20 and 9/14 is our answer. Let's check it, and we got it right. All right, subtraction, nothing really too crazy for this first one. 13 over 14 minus 9 over 14, same as adding. If the bottoms match, just subtract the tops. 13 minus 9 is 4, so you get 4/14, which reduces to 2/7 because 2 goes into both 4 twice and 14 7 times. Don't worry, this will get harder. Here we go. 77 minus 7, both over 200. You're just going to do 77 minus 7, which is 70. Bottoms match, so that's 70 over 200. And if you try and write that as your answer, it's going to be wrong. It's wrong for 2 reasons. Oh, first of all, I typed over 100 instead of 200. Silly me, right? I wasn't paying attention. I did that on purpose. So let's try 70 over 200. Oh no, that's wrong too. I've only got one more try. I don't want to get it wrong on the 3rd try and have to start over. Well, okay, so these are supposed to reduce, I guess, right? All right, well, what can I do? They both end in 0. That means 10 goes into both of them. The cool thing about zeros is if they have trailing zeros, you can just you can cross them out one by one. Now I can't get rid of the other 0 because there isn't a second 0 in the top to cancel the second one at the bottom. So that's just 7 over 20. There's no other number that goes into both of those. So that should be right. Oh, I hope it's right. All right, cool, it is. Again, I'm the mindset of a student there. We'll do this one as well. 38 over 20 minus 18 over 20. I like this one. Common denominator, just subtract the tops. 38 minus 18 is 20. 20 over 20. Oh, well, they both end in 0, so cancel them. Oh, they're both 2, so divide them. 2 divided by 2 is 1. Or you just say 20 divided by 20 is 1. Maybe you do it this way. Maybe you do it this way. Maybe you said it's 1 over 1 because you said, oh, 20 goes in that once and into that once. I'll bet you they say it's wrong. And they do. Because 1 divided by 1 is the simplest thing you can do with division. It's 1. My math lab doesn't like 1s and bottoms for answers. All right. 5 over 6 minus 1 over 4. You got to get an LCD this time. If you do your multiples, 6, 12, 18, 24, 4, 8, 12, 12. So 12 is your LCD. If you break these down in primes, 6 is 2 times 3, 4 is 2 times 2. So you'd need 2 2s and a 3. 2 times 2 is 4, times 3 is 12. Rewrite these with the new denominator. Keep the arithmetic the same. 6 goes into 12 twice, 2 times 5 is 10. I'm telling you, if you practice this 100 times, you'll start just railing through them really quickly. You don't do things well without practice in general. 4 goes into 12 3 times 1 is 3. No one's going to do it that quick the first 10 times. Maybe not even the first 20 times. But by the time you do that 150th one, you will. Expand your mind. Growth mindset. All right, 10 minus 3. I mean, we're technically borrowing there. Borrow from the 1 and make the 0 a 10, but it doesn't feel like anything actually changes, right? Nobody shows that borrowing. 10 minus 3 is 7 over 12. Final answer, nothing reduces. I wrote 10. Oh no, we made a typo. There we go, 7/12. Cool. All right. Not interesting. More of the same, more of the same. Here we go. This is what I wanted to get to. And I'm going to do a counter problem to this that I had mentioned much, much earlier. It was this thing. So we talked about how with subtraction, if the blank's on the bottom, it's not really bad. I'm over here on the blue squiggly circle where my mouse is hovering. If you do 7 4/5 minus 2, 4/5 minus nothing is 4/5. This is easy. When it's the other way, that's where we have to do that borrowing, and that's the situation here. If the 4/5 was with the 3, this would be a ridiculously easy problem, but it's not, so it's not. So 3 minus 1 4/5. Once again, I believe it's easier to stack these vertically, but that's an opinion. Your opinion may vary. So I need to put a fraction here, but I can't just pull one out of thin air. I got to borrow. So we're going to borrow from the 3, making it a 2. I'm borrowing a single whole, which is why the 3 has dropped down by 1 whole. But that 1 whole I'm going to be putting here, but I'm not going to write it as 1. I want to write it as a fraction. And 1 whole is always the same number top and bottom, 3/3. So I could do this if I wanted to, but it's not constructive because these numbers don't match. I could make it 17/17. That's still 1 whole, but then the denominators don't match. I could make this 50,000 over 50,000. I'm still borrowing 1 whole. I'm just choosing to write it in a horrible way because these bottoms don't match. So, oops, why not just go ahead and make this fraction match the bottom? So since that denominator is a 5, just make this a 5, top and bottom. 5 divided by 5 is 1, so that 1 whole was the 1 we borrowed from the 3 and made a 2. Now we're ready to do our subtractions. 5 minus 4 is 1, so that's 1/5. 2 minus 1 is 1, so the answer should be 1 1/5. Drum roll. There we go. We got it. All right. What if we had 5 2/5 minus 2 4/5? Oh, okay, well, this thing's got a top fraction, so there's no borrowing. You just do 2 minus 4, and you get, wait a minute. Mr. Beckner said you can't do subtraction that way inside of an actual subtraction problem. If the whole thing is just 2 minus 4, it's -2. But you can't say this is -2/5. That's terrible. That's awful. Don't you dare. Because there's other things involved. You can't do negatives in one part and not in the other. So even though that top part was there, it wasn't missing like the previous problem, you still need to borrow. So from the 5, you borrow a whole, which drops the 5 down to a 4. Now that whole that you're borrowing, instead of just placing it here, you're now adding it to the fraction. But again, this is a bad idea. You don't want to write it that way because then you've got to go through the process of saying, well, what's my LCD? I got to get my LCD. Tedious, tedious, tedious. So instead of writing it as 1 whole, you write it as a fraction, same number top and bottom. Like 3/3 maybe. They don't match, so that's a bad idea. So how on earth do I figure out what number to write it as? Don't overthink it. It's staring you in the face. Whatever that denominator is what you should make this thing top and bottom. There's our 1 whole that we borrowed from the 5 that made it a 4. We just wrote it conveniently so that these match, so we can very easily combine the 2/5 and the 5/5. So let's say this is equal to, now it's 4 7/5 minus 2 4/5. 7 minus 4 is 3. Keep the denominator. 4 minus 2 is 2. Boom. Mixed number. I did not hit mixed number. Mixed number, please and thank you. 2 3/5. 2 arrow, 3 arrow, 5. It was being funny. There we go. All right, what about mixture problems if you've got adding and subtracting? Does that change the game horribly? No, not really. I have run out of room. That's going to look ugly, but it won't matter. I don't save these anyways. 19 over 27 plus 11 over 18 minus 3 over 10. This might be the last one we get to. Yes, it will be. So with these double-digit denominators that have matching factors, 2 goes into 18 and 10, 3 goes into 27 and 18, and there might even be more numbers than that. I'm going to tell you that it's likely that the multiples are going to take a long time. So I'm not going to list the multiples. I'm going to say, all right, 27, when you break it down, is 3 times 3 times 3. You might just first say 27 is 9 times 3, but 9 is a pair of 3s itself. 18, you could say is 2 times 9, which is 2 times 3 times 3. And then 10 is 2 times 5. Meaning our LCD needs all the different factors, 2s, 3s, and 5, 2s, 3s, and 5s, but you need the most of each of them. There's only a single 2 in the options, single 2, so we just need a single 2. There's only a single 5, so we only need a single 5. But the 3s, there's 2 of them here and 3 of them here, which means we need 3 of them in the LCD. So our LCD is 2 times 3 times 3 times 3 times 5. Which is, let's see, 2 times 27 is 54. Half of 54 is 27, added 0, so 270. If you don't trust me there, you pull out your calculator, because I know I said something very weird probably. 2 times 3, 3, 3, and 5. 270. What was that thing I just said? I like giving my little arithmetic tricks. I had my 27, I'm sorry, I had my 54, which was the 2 times the 3s. That was 54. And then when I wanted to do 54 times 5, I said, all right, half of 54 is 27, and then I tacked on a 0. That was me multiplying by 10 and halving it, because half of 10 is 5. It's just a cool arithmetic trick that can help you manipulate numbers in your head if you don't have paper or a calculator. Kind of in the same way that I figure out if a number goes into 3 by adding the digits. And if that's divisible by 3. All right, so new denominators are 270. If you didn't like that little trick I said, don't use it. New numerators. 27 is going to go into 270 10 times. 10 times 19 is 190. The cool trick I mentioned before, 27 to 270, well, 27 was the 3s. If you ignore them, you've got 2 times 5. So that's what you multiply the 19 by, 10. 19 times 10 is 190. 18 into 270, well, that was a 2 and a pair of 3s. So that would leave us with 3 times 5, which is 15. So we're going to take 15 times 11, which is 165. If you don't trust me, 270 divided by 18 is the 15 times the 11, and you get 165. For the last one, 10 is the 2 times the 5, so you can cover them up. What do you see left? That's 27. And then 27 times 3, you might, oh, that's annoying, 27 times 3, 27, 54, 81 if you add them up. But yes, it's 81. Oops. Let me just go back. I don't want to keep that scribbled out. 81. There we go. All right. So we take our 190 plus our 165. And if you don't like doing that on your own, you use your calculator if you really want. It's not the end of the world. I'm not going to cry in this course. And you get 355. But then we're going to subtract the 81. And you get 274. Over the 270 that remain there. Now, maybe you want to double check that. 190 plus 165 minus, you can type it all at once in a calculator, 81, and you get still the 274. But these are both even numbers, so we can divide them both by 2. 274 divided by 2 is 137. 270 divided by 2 is going to end up being 135, but I'll show it. 270 divided by 2, we get 135. And that's going to be the answer. It won't be, you won't be able to reduce that anymore. 137 over 135. They said type a whole number, a fraction, or a mixed number. When they say fraction, they mean proper or improper. And we got it right. Fill in the blank with the most appropriate term or phrase. We'll do this one really quickly since it's a fill in the blank. To find the product of the fractions 1/7 and 5/8, the 1, the 5, and the 7 and the 8. Let's see what our options are. Add, multiply, subtract, or divide. So they're saying they want us to multiply 1/7 and 5/8. 5/8. They want us to do this. So as a reminder, there is no LCD for multiplication or division. You just go straight across for multiplication. For division, you flip the thing after division and change it to multiplication. And again, you go straight across. It's not just the bottoms, it's not just the tops, it's both. You are multiplying the 1 and the 5, which would give us 5, and then you'd multiply the 7 and the 8, which would give us 56. They didn't ask for the answer, but there it is. All right, so we're going to call it there. So we did a whole bunch of these. I focused on the first half of them. I didn't bounce around like I do sometimes because I wanted to focus more on the adding and subtracting because that is where people struggle. Now, you might be thinking, Mr. Beckner, I didn't need to learn any of this. You said we're allowed calculators. Calculators do some weird things with fractions, though. When you type, oh, the answer is going to be 2/7. So maybe it was, I don't know, 4 divided by 14. So you type, oh, 4 divided by 14 in your calculator, and it gives you this answer. Well, calculator, what's the answer as a fraction? Some will tell you if you know what button to hit, it's magical. Many won't, though. So that's why I need to focus so much on fraction math. Yes, it's true that we won't do that much fraction math this semester. We do a little here and there. We actually did one today, in fact, where I had the half a bowl of cereal and a quarter of a bowl of cereal, and we added them. Even though I changed them to decimals because they were what we call pretty fractions. Pretty fractions meaning that their decimal values terminate and rather quickly. Ugly fractions like that 2/7 do not do that, and calculators hate them. Things with thirds. 1/3 is 0.3333333333, and you can't just say it's 0.3 or 0.33, it's 0.3 bar. But I don't even think you can put a bar in your answer in my math lab, so that would not be fine, especially if they say write the answer as a fraction. All right, so please remember that y'all are supposed to be doing these assignments.
All right, so that's what we're going to call it for the day. So hopefully this fraction math stuff was informative. Like I was just saying, it's not something that is going to be super heavily required throughout the Math 154 course, but it does occasionally come up where your calculator is not going to be able to do absolutely everything for you. Yes, the discussion is only for the first 12 students, unless a 13th or 14th student comes in to correct something or to add something significant. I believe the next discussion board will be another one where everyone will have an opportunity, but don't hold me to that at the moment. But yeah, that aside, we'll come back on Wednesday, and then another reminder that we will not have class the following Monday and Wednesday because it will be spring break. So we come back on March 2nd, this Wednesday for class, and then we'll be back on, what is it, the 14th. I think that's the following Monday. All right, so keep working hard, keep working on that homework. Remember, you do want to be getting 70s on all those assignments. I'm probably going to be withdrawing a couple people during spring break if you haven't really done anything or you've only done 1 or 2 things from the MDE section. And that's not really the case for most everybody, but I do have at least 1 or 2. So if that's you, please try and catch up. This is going to be one of your last opportunities, and I don't want to withdraw any students. I want you to stay. I want you to pass. I want you to do well. All right, so enjoy your day, and we will see you on Wednesday. Take care.